as a power plant, basically a power plant. So I've tried to simplify what you have in the notes so that you can be able to look at what we have here. So in the internal combustion engine, you have different types of internal combustion engines. So we have those that we call the four-stroke cycle internal combustion engines, those that are based on the four-stroke, and those that are based on the two-stroke cycle. And if you remember the lecture that we had on Saturday last week, is that the two-stroke cycle was the first type of an engine that was developed. Then later, there was need to separate the different kinds of processes. Okay, so each and every process is like four separate processes. Okay, so you have four separate processes that define a single cycle of the operation of an engine. Now, so in the first cycle, what you can see there in the first cycle, this type of an engine that you are seeing is a typical spark ignition engine. So if you see a spark plug in a Manisha, it means that it requires an external source of ignition to ignite the air fuel mixture. Okay, so you can also see there's air plus fuel. So where you see that green arrow of air plus fuel, we call it the intake manifold. Okay, so the intake manifold, you have quite a number of things in the intake manifold. One, you have the fuel injection system. So a fuel injection system could be something like a carburetor, for instance, that take fuel from the fuel tank, and then the work of the carburetor, the classical carburetor and the conventional type of carburetor, is that one is that it first of all has to atomize fuel. So fuel cannot burn when it's while it's in liquid form. So it has to be broken down into very tiny, like the tiny mist. Okay, you can think of it as a very tiny particles. Okay, and you can know that if, for example, you've poured petrol and lit fire on that petrol. Okay, assuming that you pour it on the ground and it forms a pool of petrol. Now weke maji. I mean, you light a fire near it. You'll only see the top burning. Okay, you won't see the whole of it engulfed in flames and all that. Okay, so it means that it's only the part that vaporizes that burns. So liquid petrol, any other type of fuel, generally does not burn in its liquid forms. It usually has to vaporize. Okay, it has to vaporize and then it burns. So now the work of the carburetor or any fuel injection system, like it could be an electronic fuel injection system, is to atomize. The next thing is that it also premixes air and fuel in a definite ratio. That ratio, we call it the air-fuel ratio. Okay, so you need to remember the term. So the air-fuel ratio is a specific type of ratio in which air and fuel has to be mixed. Now, when we say the air-fuel ratio, you generally have an air-fuel ratio. Ideally, we normally have an air-fuel ratio of kitu kama 14:1. So which means 14 parts of air to 1 part of fuel. So you need 14 parts of air to combust 1 part of fuel, or 14 volumes of air to combust 1 volume of air. So this is a ratio, all right? So it means that if you have a certain volume of air and a certain volume of fuel that is being mixed, if you simplified those two volumes in a ratio, around 14:1, but it can vary. I mean, I'm just giving a number, something like 14:1, for instance, can be 13.5 or 15. It really depends on whatever it is you're using for. Now, another thing to notice is that the air-fuel ratio, the reason why you have more air than the amount of fuel in terms of the ratios is that in the air, you're only interested in oxygen in that air. Okay, you're only interested in the oxygen. So the oxygen that is inside there is about 21 to 23% in 100% of air. So if you have a volume of air, say 5 liters of air, atmospheric air, about 21 to 23% is oxygen. Okay, Another percentage, about 78%, is usually nitrogen. Then we have other things like nitrogen. We have things like sulfur in the air. We have suspended particles. We have these unreactive gases. Sometimes they are called inert gases, argon, helium. Okay, those ones are usually just smaller percentages. So the reason why you have more parts of air is because in that air, you require more of it to get that 23%, a sufficient amount of that 23%. So because oxygen yakwanga tu ni kidogo sana, around 21%, you need more of it so that you can get sufficient amount of oxygen to combust the air fuel mixture. Now, oxygen is important in the combustion process. So it doesn't get used up in the combustion process. Okay? It doesn't get used up in the combustion process. It only supports the combustion process. Okay? It only supports the combustion process. So, for example, if you're burning carbon, what oxygen does is that in the presence of that high temperature that is created by the combustion process, it simply combines with carbon. The oxygen atom combines with carbon to form CO2. So it's not being used up. Okay, it's simply being combined with another one. So never say that oxygen burns. Oxygen does not burn. Okay, so it's only important in the combustion process because the combustion cannot happen without the presence of oxygen. But in the process, the oxygen molecule simply attach itself to other parts of the reactants to form new compounds. For example, if the reactant is carbon, okay, inaweza kuwa maybe it's just a piece of wood that has a lot of carbon, okay, it will form CO2, okay. Some that will be unburnt will remain as carbon, okay. So I'm talking about the air fuel mixture now. Now, so the air will come in, and remember here, these are very conventional type of fuel. I want you to note that as we talk about air fuel coming in for spark ignition engines, so we have air fuel coming into the to the cylinder. We have some types of engines that have direct injection of gasoline. You've seen vehicles written DIG, for example, kama Nissan Notes, utapata imeandikwa DIG, inamaanisha direct injection gasoline. So again, air fuel can come from the intake manifold. They are premixed, but in some cases, there's direct injection of gasoline, just like as you'd find in diesel engines. Okay. Now, so air fuel comes in. Okay, it will come in. The piston will move downwards. During that time, the intake valve is open while the exhaust valve is closed. So it's very simple, pretty much simple. So the valve, the intake valve will be open. Then the piston will move downwards. Now, as the piston moves downwards, I wanted to note one thing, that there is some form of negative pressure that is initially created by the piston moving downwards. Sometimes it's not very noticeable, but remember that the rate at which the air fuel comes in and the rate at which the piston moves downwards are not the same. So usually the piston moves downwards faster than the rate at which air fuel comes in. So at some point it creates some negative pressure. The topmost parts in which the piston can go is normally known as the top dead center, TDC. The least part of travel is normally known as the BDC, bottom dead center. The difference between the bottom dead center and the top dead center is known as the stroke. It's a length that is normally given there. It's normally known as a stroke. So as the piston moves downwards, it normally creates that negative pressure, but usually the negative pressure situation does not stay for long. So it usually just comes downwards, and then at the end of that, we call it the intake stroke. At the end of the intake stroke, the intake valve closes. Now, during that time, the exhaust valve would be closed. Now, in the next cycle, because both valves will be closed, the piston will move up. Now, as the piston moves up, I want you to note this, that there's no chance for the intake gases to escape anyway. So the compression process presses or forces the molecules of air and fuel closer together. When they are forced closer together, something happens. I know you probably learned about Brownian motion of matter. So if they are forced closer together, they will gain more energy. So they tend to vibrate more. Think of, for example, if you have cows and you kitambo tulikuwa tunapeleka kwa cattle dip and you sort of press them towards too close to each other. Maybe you are confining them in an enclosure where they are too close to each other. You'll see them attempting to, look for space and trying to move around. There'll be a lot of commotion. But if you give them more space, you'll see them less active. They are not bumping into each other. But the way molecules behave is the same thing. They come closer together, they'll gain some kinetic energy. There'll be a lot of activity. There'll be a lot of vibration. That kinetic energy, if there's a raise in kinetic energy, temperature always rises up. Another thing that happens is that the pressure also goes up. So in those conditions, usually there's something known as a distributor that is synchronized with the movement of both the cam, because the cam is what controls. You can see there's a place imeandikwa camshaft. So the camshaft, which has the cams, is synchronized together with the distributor. So towards the end of compression stroke, usually around 20 degrees ATDC, BTDC, that is before the TDC, about 20 degrees before the TDC, the battery, there will be a circuit that is completed. It's known as the ignition system. So in the ignition system, a huge current from the battery will be drawn into the spark plug, and the spark plug will simply ignite. We'll talk about the mechanisms later, but it will ignite the air-fuel mixture. Now, the reason why the ignition process is very simple at this time is because of this, that there is already a raised energy field in the air-fuel mixture. I've talked about the kinetic energy being raised, the vibrating particles and all that. There's a raised temperature. There's a higher pressure. There is also, this environment is also rich in oxygen. This environment is also rich in fuel. So which means that you only need a very tiny spark in order to be able to combust the air-fuel mixture. Now the combustion process will push the piston downwards in the next cycle, which we call the power stroke. Now this cycle is the most important because it happens without any assistance. So here the piston will move downwards without any assistance whatsoever. It does not need any assistance to move down. But in intake and compression, for the piston to move up, it needs some extra assistance. And that extra assistance is normally provided for by what you call the flywheel. So the flywheel, because of its mass and geometry, it contains potential energy. So, and it's connected to the crankshaft. So that potential energy, during starting, that potential energy is normally converted into kinetic energy. And that kinetic energy is the one that pushes the piston up and down during intake, compression, and exhaust. It's only in power stroke that the piston comes downwards without any form of assistance. And that point is known thermodynamically as a heat addition process. Okay? So it's a heat addition process, a thermodynamic process. Okay? So it will be pushed downwards, and that downward movement will produce kinetic energy, which will be taken and stored by the flywheel as potential energy. So it is at the power stroke where you have the reverse transfer of energy. So remember, the piston and crankshaft operate through kinetic energy, the movement, while the flywheel contains potential energy. So potential energy is converted into kinetic energy to operate intake, compression, and exhaust. So one way of power, from conservation of energy equation, okay? The energy flow equation, probably you've done it in thermodynamics. Kuna kitu inaitwa steady flow energy equation. So in that steady flow energy equation, there's a conservation of energy within that system. So if the flywheel supplies kinetic and potential energy for kinetic operation or kinetic energy to operate okay, it converts its potential energy to kinetic energy to operate intake, compression, and exhaust, then there has to be a reverse process so that there is energy conservation. So energy cannot only travel one way. So the or reverse process is through power stroke, where power stroke you produce kinetic energy, it will travel to the flywheel through the crankshaft, and that energy will be stored as potential energy. And then the engine will now convert, because the rotating crankshaft will immediately convert that potential energy into kinetic energy to operate exhaust, intake, and compression. And then the reverse process occurs. So it obeys the first law of thermodynamics. If you know the first law of thermodynamics, what it means, I know you know what it talks about. It's all about conservation of energy. Okay, conservation. You cannot create or destroy energy. So it is just a self-sustaining system. Okay, so during exhaust stroke, towards the end of power stroke, the exhaust valve usually starts to open. So the exhaust stroke does not occur as the piston is moving upwards. So usually the opening and closing of the exhaust valve does not wait for the piston to get downwards. So usually a few degrees before BDC, okay, pale chini, before BDC, the exhaust valve will start opening, and some gases of combustion will rush out, because usually at that point there is too much pressure created in the combusting gases that when the exhaust valve opens, just for a tiny fraction, most of those exhaust gases will be expelled. Now, because there will be some residual exhaust gases, you require the exhaust stroke now to push out whatever is remaining. Okay, so it will move upwards. Now, as the piston moves upwards in exhaust stroke, two things will be happening. The exhaust valve will be gradually closing, while the intake valve will be gradually opening in readiness for the intake stroke. So those two processes occur at the same time because of the specific design of the cams. So the cams are such that the exhaust valve and intake valves usually open gradually relative to each other. So which means that there's a point where both of them will be partially open. So when both are partially open, it means therefore that there are chances that as you are letting in air and fuel, okay, as you're letting in air and fuel, some of the exhaust gases have not completely left. So therefore, it means that there's a chance that the air and fuel and the exhaust gases are going to mix. So that potential for mixing between the intake gases, so that is air and fuel, and exhaust gases, is what contributes to the inefficiencies of this engine. Okay, the internal combustion engine. So it's a kind of it's a problem that is commonly observed. It's what contributes to their thermal inefficiency. So there's something called thermal efficiency. Okay, because it means that once the exhaust gases, the exhaust valve has closed, and not all the exhaust gases have left, then in the next cycle, that is during compression and power, we'll be combusting air and fuel plus some products of combustion, which cannot be combusted any further. Some of those products could be CO2, H2O gas, that is mist, water vapor, etc., or CO. So they have no further possibility, or like for example, CO2 cannot easily be broken down, even in the high temperatures in the cylinder. Okay, so chances are, I mean, what normally happens is that the CO2 will simply just stay and it will just be occupying a part. I mean, it's just part of the combustion process. It's part of the reactants, but it cannot react to produce anything. It's just part of the reactants, but it cannot react to produce anything. So the fact that you can have some of the volume of air and of intake gases being taken up by gases that cannot react to produce anything, it is what normally causes loss in both volumetric efficiency and loss in thermal efficiency of the engine. So that is the four-stroke cycle. So here I have So here we have the two-stroke. Let me just show you something. Okay, I think I need to, there's something I need to put here because let me just check. I think there's something I have here. I probably did not include. Just give me a minute to, I think I may have, just a minute. I need to confirm the slide which I placed there. Okay, yeah. So let me just replace this slide with another one meanwhile, so that there's something I wanted to show. I think I later added something but did not update this specific one, so I'm just going to add a new one. Okay. Just a minute. So anyway, so the two-stroke engine, you can be able to see the two-stroke engine. So two-stroke engines are slightly different from the four-stroke cycles. The way they operate is usually slightly different. So I just wanted to show you, yes, this one here. Okay. So in the, I don't know if, I don't know to what extent this one can, okay, this one can't, I actually expected the animation. So this is an animation. I actually thought there's a way in which I can make this animation to work, but it seems I can't. Okay. Like the animation can't work, but I'll send you this so you can be able to see. So just an animation that was showing the way the four-stroke cycle works. But anyway, so generally what we have here, there's something I wanted to just mention, something known as the firing order in a four-stroke cycle. So in a four-stroke cycle, if you see the image on the left-hand side of the screen, you can see that there are different stages. The first cylinder. So you have these are four-cylinder engine. You can see there are four cylinders. So at any given time, there are usually two cylinders. Sorry, the orientation of the crankshaft. It's like that there are usually two cylinders that are. There are usually two cylinders. Yeah, thank you, John. So there are usually two cylinders that are usually not two cylinders, but two pistons that are usually up and two that are usually down. Now, in this very specific design that you see here, if we were to count the cylinder, if we were to now place a number on the pistons that you see, you can assume that they are inside cylinders. The way we normally count is that we normally place the first cylinder as the one that is nearest to what we call the flywheel end. Now, in this case, the right-hand side is the flywheel end. Okay. The rear end of the engine is normally regarded as where you have when you normally have the flywheel. So from the flywheel, normally have the connection to the clutch, then as well as now to the transmission system. Okay. So in the front side, what you normally regard as the front side, even when it comes to numbering, the first or the one that is nearest to the flywheel end, because you normally have a flywheel that is connected to a belt and pulley system that is used to operate other mechanical systems, for example, the alternator, for instance. Okay, so now you have the first cylinder. Okay, now that is nearest. You can see there on the right hand side that is the first cylinder, then the second, the third, and the fourth. Now, if you see the fourth one, you can see that it is in the combustion, there's a combustion process that is happening. So it means that is the commencement of power stroke. Okay. There's the next one after that, you can see there, it is in exhaust. Okay. No, I believe it's probably combustion actually. Yes, I think it's combustion. No. The first one is combustion. Then the second one is, I believe that is, yeah, that is exhaust. And then the green part, okay, the green one is intake, okay. And then there is compression. So the one that is on the far right is undergoing compression, okay. So now I want us to make to find how then do we determine the firing order. Na nataka tutumie this, I just want us to use this, what we have here. Nataka tutaitumia hii so that we can be able to write the firing order. Okay, so I want us to have something like this, maybe a table like this. I'm just going to use this table like this here. I'm hoping that I can be able to make a good sketch here. Okay, so we have cylinder number 1, 2, cylinder number 3, cylinder number 4. Okay, now what you should note is this, that in determining the firing order, so firing order is basically the sequence in which the cylinders fire. Okay, so the cylinders will not fire at the same time. Okay, so they usually fire in sequence. So nataka tutumie that image that you are seeing on this image to be able to see if we can determine. Now, the crankshaft rotates for every full cycle. Okay, that is all the 4 strokes for them to happen. The crankshaft usually rotates 720 degrees. Okay, so in the first, so in stroke number, I don't want to confuse the numbers. In the first 180 degrees, let me call it the first 180 degrees. Okay, maybe F, the first 180 degrees, the second 180 degrees, because every 180 degree rotation of the crankshaft, the piston moves up. Another 180 degrees, it moves down. That's a stroke. Okay, so the second, the third, and then the fourth. Okay, so you can see the cylinder number 1. So cylinder number 1 is undergoing power stroke. Cylinder number 1 is undergoing power stroke. So cylinder number 2, so I want to, okay, let me first of all number them. Nataka tu change numbering based on this. So in your cylinder number 1, this is cylinder number 2, this is 3, this is 4. Okay, now so this one mumeiona iko, let's assume that this is power stroke. So at that point, power stroke, remember this piston is coming downwards. This very specific one, assume that it's coming downwards at this very moment. Okay, if it is coming down at that very moment, there's a combustion process, so that is power stroke. Ndio maana nimeweka cylinder number 1 power stroke. Now cylinder number 2, 2 things can be happening. So if this is coming downwards, hii lazima itakuwa inaenda juu na hii pia inaenda juu, so this one is going up, then this one is also going up, na hii inakuja chini. Now, so this one is coming down as during power stroke. Now this one can move up for any 2 possible reasons. Assume that we don't even know what is happening. It can go up due to 2 different reasons. One is that this one could be having compression. Okay, inaweza kuwa ni compression. And if this one is undergoing compression, then this one can go up, not for the same reason as compression. It could be exhaust. Okay, so it could be exhaust. Okay, so and then this one itakuwa ni intake. So let's see. So let's assume that this one can come down for any 2 reasons. Okay, sorry, this one can go up for any 2 reasons. So let's assume that for the reason that it's going up, it is exhaust. So nataka tuweke ikwe exhaust. Okay, and then The next one is going to be, so it can go up as a result of compression. So it can go up for during compression. Now the fourth one, this one sasa, let's say itakuwa sasa intake. There's no other possibility. So it can only be intake. So the only places tunaweza switch ni hii. So either equal compression na equal exhaust, ama equal exhaust compression. Those are the only two possibilities. Now in the next cycle now, okay, let's assume that this one ishakuja chini. So the next cycle is when now this one moves up. So after power, now the sequence is that after power stroke, we normally go to exhaust. Okay. And then after exhaust, you normally go to intake. Okay. And then after intake, we normally go to compression. Now let's go to this one. So after exhaust, you normally go to intake. After intake, you normally go to compression. After compression, you normally go to power stroke. Now after compression here, you normally go to power. After power stroke, you go to exhaust. You can fill this table on your own. This one goes to intake. Now after intake, this one unaenda, okay, the normal one, so it's just compression, power, exhaust. So nataka sasa tuende sequence ya which one fires first followed by what. So kwa hii line, power stroke iko kwa which cylinder? Cylinder number 1. Now kwa hii line. Now in the next one, this line, power stroke iko wapi? Kwa cylinder number 3. This one right here. So we say 3. Now that is the second line. In the third line, which one is in power stroke? I mean, which one achieves power? Cylinder number 4. You can see this one here. This one right here. So cylinder number 4. Okay. And then finally, cylinder number 2. You can see here. Cylinder number 2. Now, that is an order in which power stroke occurs. Okay, so this is what is known as the firing order. Okay, the firing order. So firing order. Okay, that is the firing order. Now, so that is just one of the possible firing orders. 1, 3, 4, 2. Now, you can also switch, by the, if you also switch this one, equal compression instead, this one equal compression, now equal exhausts. If you switch this table, you can switch those two now, okay, and find the firing order. So I'll give a chance, so somebody atuambie what firing order would occur if we had PCEI, that is power, compression, exhaust, intake. What firing order would occur? And hiyo kazi nitapatia Moses. So if Moses uko tuambie ile firing order itatokelezea from if you now switched that kuweka na, I mean if you switched the way I've shown you. So develop a new table na uniambie firing order. Moses uko hapo? Are you there Moses? First of all, isikuwe nimepea mtu something na labda is not online. Moses, are you there? Moses? Okay. Patrick? 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 Eliud Maina? Eliud?
Yes. Could you repeat your question?
Yeah, so I need you to produce a new firing order based on a new, so I've switched, if you see this one, initially tulikuwa na power hapa, kwa cylinder number 2 ilikuwa exhaust, compression, intake. Now I have switched it to power, compression, exhaust, intake. So uko na ile line ya kwanza. I want you to fill the other 3 lines, this one, this one, and this one, and then produce a new firing order. Umeelewa?
Yeah, 4, 3, 2, 1.
No. You'll still have to start with 1. I mean, I've not changed. The first cylinder will still be the first one to fire. Are you sure it's 4, 3, 2, 1?
No. 1, 2.
Okay, naona John umeandika 4, 2. No. The first one, we are not changing. The first cylinder will still be the first one to fire. So munajaza this, yes. Okay, Peter Chege, thank you. 1, 2, 4, 3. Yes. So itakuwa 1, 2, then 4, 3. So that will be the new firing order. Okay, asante. So that will be the new firing order. Asante. So now this new firing order, so those are the 2 possible firing orders. Now, why is this firing order is important? Okay, wacha tu nieleze why this firing order is important. So I want you to imagine a beam like that. I know you've done structural analysis of beams. A beam that is simply supported like this. Okay, and then I am subdividing this beam into 4 equal parts like this. Okay, these are 4 discrete. I'm subdivided into so many of them. So assuming that you have a force here, because remember that there is a very huge pressure that is produced during power stroke. And we know that pressure, force, and area have a relationship. Okay, P equals to F over A. Okay, so that's the area on the top of the piston, this kind of area here, as well as the pressure due to the combustion process produces a certain force F. So this is the F here. Okay, so this is the F. So we assume that F, if it is placed on the first cylinder, the next force cannot be on the just next cylinder, and then the third one, and then the fourth one. So this, assuming that this is a beam, then this beam here is the crankshaft. So this is a crankshaft. Okay, that beam is a crankshaft. This one right here. So the crankshaft can only withstand a certain amount of stress produced in a linear manner. So it is supported here and here. So assume that it is simply supported. Because anyway, the crankshaft is basically placed on 2 ends. Remember that it's supported here and here. Okay, so if you had a force, the firing order being 1, then 2, 3, 4, 5, like that, depending on the number of cylinders, then it would create a lot of undue stress on the crankshaft. So the stress needs or requires to be distributed in a certain manner such that the stress does not build up on a single section of this of the crankshaft. So generally what happens is that you normally have, if for example in the first one is 1, then you go to cylinder number 3, the cylinder number 4, then you come to 1. Okay, you come to cylinder number 2, and then you come to 1. Then you jump to 4, 2, 1, 3, 4, 2, like that. So that kind of an alternation is caused by, is usually a very good way of ensuring that there is even pressure, stress distribution on the rotating crankshaft. So it's a very, very important and critical thing. Now, There's also something else that I will also need to mention is that so in the crankshaft there has to be as you can see there in the image on this image here on the on the left. Now in that image you can be able to see that the crankshaft is synchronized with the camshaft. So this is a camshaft. This is a type of a shaft. You call it the overhead camshaft. So it's synchronized using this chain or belt. Okay, call it the timing belt or the timing chain. So it synchronizes the motion of the camshaft, which controls the opening and closing of the valves, as well as the rotating camshaft, which controls the movement up and down, the reciprocating motion of the reciprocating motion of the pistons. Okay, so that is generally what happens there. So the firing order is very important because the firing order. You remember I said that there is a distributor, so usually have a distributor, okay, which has 4 points if it is a 4-cylinder engine. So it has 4 points, and in each point has a contact or a contactor that distributes the the battery current to each engine using the firing order. Inaweza kuwa ni 1 3 4, utapata hii ni ya 4 5 sorry 1 3 4 2. Okay, so utapata it goes to cylinder 1, then cylinder number 3, then 4, then 2. So usually the distributor huwa ina rotate like that. So there's a contactor that rotates and it distributes the current in line with the firing order. So the distributor as well is also normally synchronized together to operate with the crankshaft as well as the camshaft. So all of them have to be synchronized together. And even the injection of the fuel, also the timing of the fuel injection as well. So which means the firing order, valve timing, that is opening and closing. So the valve timing as well as ignition timing all have to be synchronized. The firing order, ignition timing, and the valve timing all have to be synchronized. Now, in modern vehicles, we have distributorless systems, so that the ignition timing is controlled directly by the ECU, the electronic control module. Okay, so it's controlled directly by the ECU. All right, so the ECU simply determines at what point the firing occurs. Okay, according to the firing order. Also, valves with modern vehicles, the valves are not completely controlled by the camshafts. Okay, so for example, in VVTi systems or the iVTEC systems in Honda, VVTi systems in Toyota, we have variable valve timing. Okay, with intelligence. So you have the ECU also controlling the timing of opening and closing of the valves. So again, it's also a changing technology. The technology is also changing, so that you don't have the the valves, the opening and closing of the valves being a sole preserve or a sole function of the cams. Sometimes, for example, with the VVTi, you have cases where the valves close earlier than expected or later than it would ordinarily close. The same thing also happens with the ignition. Sometimes ignition occurs slightly earlier. Sometimes ignition occurs slightly later than expected. So it's something that is just usually there in between. Okay. Now moving on. So that is a two-stroke cycle. This one is also an linear. I don't know how to play this, but it's an animation, but nitawatumia mtaweza kuiona. So kwa two-stroke cycle, there are two main things. I'm just going to mention them very quickly. So hapa uko na kitu inaitwa intake port. We have an exhaust port. Na hapa inaitwa transfer port. Transfer. Okay, transfer port. Okay, so this is a transfer port. Okay, so the transfer port, so I'll just mention it very quickly what it does. Now here during the up movement or the now the direction, so this is the direction of movement of the piston. Okay, so as the piston is moving upwards, you'll see that even at this particular point the intake port is exposed. Okay, so the intake port is exposed. So here is where you have air and fuel coming in. You can see here at this very particular point as well, the exhaust port is closed. So this is the exhaust port. So instead of valves, they have ports. Okay, port, P-O-R-T. Okay, this is intake here, chini ni intake. Okay, this is an intake port. Okay, so you can see here that air and fuel will come in and occupy the lower part. So as air and fuel is coming in, you can see here that the transfer port has also been blocked. The exhaust port has also been blocked, which means that here, right here at the top, you have the compression process happening. Okay, so you also have a compression as a process, not as a stroke. Okay, the compression process occurring. So in the movement of the piston upwards, that's a one stroke. Two things will happen. There will be an oncoming rush of air and fuel, and then there's also the compression process. You can call it a process also occurring at the same time. At the end or towards the end, where the TDC inakuanga somewhere here, then the spark will ignite the air and fuel mixture, and then the piston will be pushed downwards. So as the piston is pushed downwards, at this position, for instance, of the piston, when the piston is at this position here, you'll see that the exhaust port will be exposed. So you'll have the combustion products escaping. Now, at this very moment, just down here, you also have air and fuel which had collected at this chamber at a very high pressure, rushing upwards, okay, to the combustion chamber. They'll rush upwards because they now have, remember, as the gases exit, they exit and leave the combustion chamber almost with with very little pressure. So because of the pressure differential created between the air and fuel that had come in from the previous stroke, then they will rush upwards. Okay, so as they rush upwards, the piston will come and completely close the intake port. So there'll be no intake at that point. So there'll be an exhaust process that is happening just after, okay, the power process has already happened, of the combustion process that pushed the piston downwards. So this one will have been complete. So that cycle will have been complete. Now, so which means that one movement up and one movement down of the piston, that is a complete cycle. That's why you call it a two-stroke cycle. Okay, you can read more in your notes and you'll be able to understand. And you'll also see the animation. Once you play the animation, you'll also be able to see the way it functions. So now, one of the main disadvantages of the two-stroke cycle is that there are very high chances of air and fuel from mixing with the products of combustion. Okay, so the scavenging process is not very good here. So understand what the air and fuel will mix with the products of combustion. And also sometimes, because of the way it is designed, sometimes you also have air and fuel coming in, and because the exhaust port could be temporarily open at that point, they will rush out as well. So you also tend to lose products of, the air and fuel that is coming in, going into the exhaust manifold before the combustion process occurs. Okay, so it all contributes to what I'd call the inefficiencies of this system. Okay, so they have their own inefficiencies. So I want you to, I don't know whether it is there in your notes, but I want you to make a comparison between a four-stroke cycle and a two-stroke cycle. And I want you to compare them in terms of efficiency. Okay, efficiency, compare them maybe in terms of efficiency. Okay, power production per unit mass, or how much power is produced. Okay, maintenance, in terms of maintenance as well, how easy is it to maintain. For example, utaona kwa hizi two-stroke, so these are two-stroke single-cylinder engine. You can see these things, they're just fins. These fins are normally used for air cooling. So they normally used for air cooling. There are quite a number of applications you'll see for these single-cylinder two-stroke engines. And they're usually also, you can also see a spark plug. Anytime you see a spark plug unajua ni is a spark ignition engine, so it uses petrol as a fuel. Okay, so anytime you see this kind of an engine here, most of the time they're normally used for light power applications. You'll find them in power saws, you'll see them in lawnmowers, you'll see them in chaff cutters, things like those. Okay, even some light duty motorcycles, you'll see them being used a lot, and they play a very crucial role. One is that they are usually light enough, and the reason why they are light enough is the reason. I mean, the fact that they are light enough is the reason why they are normally portable. So because they are portable, they usually also have a simpler construction. You can see, for example, they are air-cooled engines. All right, so they have a simpler construction, so which means they also have less maintenance requirement. I mean, you can imagine how much maintenance requirements an internal combustion engine used for a car is compared to that of maybe of a chaff cutter. You can even imagine how many times maybe you change the oil and all that. So they usually have better, easier. I mean, in terms of maintenance, they usually have. They're usually much cheaper both to acquire. They have less complex. They have less complex mechanisms. For example, they do not have the complex cooling systems. Okay, as compared to those that are used by say four-cylinder, four-stroke engines, for instance. Okay, so they're usually cheaper to maintain as well. They're usually lighter and portable. So they have their own advantages, but they also have their own disadvantages. For example, I've talked about the issue of the disadvantage, the issue of maybe efficiency, for instance. So you also need to check in terms of efficiency. Okay, what are also some of the efficiencies that are associated with this? In your notes, there are also some questions which I asked. If you check in your notes, utaona pale chini there are some things that I also raised. Now, so the two-stroke cycle generally would look like that. You'll see something more or less like that. You can see that there are fins for loss that sort of enhance the loss of heat. They basically enhance heat transfer processes around the edges of the cylinder, the outer parts of the cylinder, which makes it easier for them to lose the heat that is generated as a result of the friction, the moving parts, as well as the combustion processes. So they are generally air-cooled engines, and you can see that they are usually light enough. Now, so for the car engine, you can also see, I think you can also be able to identify some of the parts here. This is a camshaft. Okay, that is a camshaft. This is a flywheel here. That is a flywheel. This is the distributor. Okay, you can see there is a distributor. So the distributor, like I said, it is the one that, so you can see that it's connected to, come on as on these parts, these dark parts here. These dark patches here is where you have the ignition coils and the spark plugs. Okay, spark plugs na ignition coils hapo ndani. Okay, so the distributor is the one that determines which spark plug receives current according to the firing order. All right, so it's connected to the battery. So there's usually a harness or a wire that goes to the battery. So it usually draws the 12 volts from the battery. But usually the current is usually too low, so that's why they also require to have an ignition coil. So we'll talk about the ignition coil. It's more or less like a transformer that simply steps up the amount of current that is coming in, so that it can be used for the ignition system. You can also see here that there is an alternator. The alternator converts the mechanical energy. You can see here kuna belt. These belts. So the belt is from you can see this is, I say that this end here is normally known as the pulley end. And the way we normally number the cylinders is that, so the cylinders or even the pistons is that we normally number them this way: 1, 2, 3, 4. Even when doing assembly, you normally have to follow that sequence. It's very important that you follow that sequence. So this is the front end of the engine. Well, this is the rear end of the engine. Okay, this is the rear end of the engine. So generally, kwa engines, we normally categorize it as that. Of course, this is a crankshaft. I say that the crankshaft rotates 720 degrees for one complete cycle. Okay, 720 degrees for one complete cycle. But for the cam, this cam here, cam in under 360 degrees. One complete cycle, the cam 360 degrees. That is one complete cycle for a four-stroke engine, to a four-stroke cycle. Okay, which means for the cam, every 90-degree rotation of the cam is a single stroke. While for the crankshaft, every 180 degrees is a single stroke. Okay, so it's very good to remember that. Now, but for two-stroke, hii crankshaft unaiona hapa. crankshaft, a complete rotation, a complete cycle is 360 degrees. So one complete revolution of the crankshaft is one complete cycle. Okay, remember that. One cycle, okay, this cycle here, this cycle, a complete cycle is composed of two strokes, which means up movement from BDC to TDC and down movement. Now that cycle is complete. So the first cycle, the crankshaft rotates 180 degrees. The second stroke, another 180 degrees, 360 degrees. Lakini kwa four stroke engine, the one cycle, that is rotation of the crankshafts by 180 degrees, pushes the piston from TDC to BDC and vice versa. Another cycle, another stroke, that is, remember, a stroke is movement from BDC to TDC and vice versa. Another 180 degrees. Another 180, another movement of the piston down or up. Okay, so which means that this one goes for a complete cycle. In a four-stroke cycle, then the crankshaft rotates two complete revolutions. So that information is very important. Tutakuja kuitumia mahali, so we'll come and use it or discuss it another day. Now I'll just mention a few things maybe when it comes to maintenance. So one thing you should know is when it comes to maintenance, like for example here we normally place the oil filter. So usually maintenance of the oil filter, maintenance usually when you talk about maintenance of an engine, we normally have quite a number of things that we look at. So there are so many. I mean, there are so many. But I want you to try and figure out what kind of maintenance programs or schedules are normally followed with an internal combustion engine, especially those that are used for mobility. So number one is that there are quite a number of things that you look at. So in here are the cylinders. That's a cylinder. You see that hole is a cylinder. Okay. So inside the cylinder, you have the pistons. Now the pistons also have piston rings. I also want you to go and read about the piston rings. There are usually 3 piston rings. This is also something I'm giving you 3 or 2 piston rings. It can be 3 or 4. So what we call the piston rings. I want you to find what the function and the purpose of the piston rings are. Okay. So piston rings are normally used for a number of things. I want you to maybe read it, and then you'll give you can be able to summarize in your notes. Okay, so find the 3 piston rings. You should be able to know the 3 of them as well as their function. So I hope that one you've noted it somewhere. So make sure that you know function of the piston rings. So that's, I can just write it in the public chat, function of the piston rings. So you should be able to name them. The piston rings, and also be able to say what the function is. Now, the piston rings usually get worn out, okay, and they can compromise the compression process. So, utapata gari iko na loss of compression. There's something known as a compression test, okay? I also want you to go and read about the compression test. What is the function of the compression test? Okay, so there's something called a compression test, and the compression test is normally done to identify whether there is sufficient compression, say for example, the end of power stroke, the end of compression stroke. So you normally check for the compression or the amount of pressure that is developed by the engine during the compression process. If, for example, you have worn out piston rings, you'll have a loss of compression. Okay, loss of compression can also be caused by other things. For example, if you have a worn out gasket, so a gasket is normally placed between here. So what you are seeing here is what you call an engine block. Okay, so what you're seeing there is an engine block. So between the engine block, where you place the engine block, and so the engine block and the engine head, you normally have a gasket. So just a seal, okay, just provides a sealing point. If that seal is broken, you'll also have loss of compression. Okay, could also have loss of compression because of if, for example, there is a cracked or the top part of the piston, which is called the piston crown, is cracked. So if it's also cracked for one reason or the other, it could be maybe just cracked. It could be a reason, quite a number of reasons for it to crack. Pistons normally operate in an environment with this constantly high pressure and constantly high temperatures. So for some reason, the material could give in and it could crack. It will also cause a loss of compression. Okay, so those are some of the things that you'll be watching out for. So if you do a compression test and you realize that there is a loss in terms of compression, then you would want to narrow down. Usually, you want to narrow down to checking, for example, the gasket. What is the condition of the gasket? Does it need replacement? Check the piston rings; they're in good condition, and it will also pinpoint which cylinder is having a loss in compression. If it could be cylinder number 3, then you check the condition of the state of the piston rings in cylinder number 3. Okay. There's also a loss of compression. There's usually a high chance that you'll also find usually some very dark deposits or usually some dark deposits around the top part of the piston. It's called the piston crown. Those dark deposits are usually a pointer that there could be also some oil leakage into a lot of oil leakage into, or a significant amount of oil leakage into the cylinder. So which means that in the combustion process, you're also combusting not just air and fuel, but also the oil. And oil is a very heavy hydrocarbon. It's a very long hydrocarbon chain, which means that it does not break down very easily even when you burn it. Okay, especially at temperatures that are as those that are found in the internal combustion engine. So utakuwa unapata a lot of dark soot and a lot of darkening along the piston crown. So it is usually a pointer of probably things to do with worn out piston rings. Now you also normally change the oil after some time. The oil change is normally carried out. It could either be from a scheduled maintenance program. Can schedule the maintenance program. But scheduling maintenance program is not also a very good way of determining when to do oil change in your car, because oil, remember, has a lot of, it has two main functions, very critical functions. One is that it lubricates the moving parts in the engine. Remember, all the parts in the engine usually operate at a very high speed, by the way. So that very high operation requires constant supply of oil. Okay, for example, the crankshaft and camshafts and all that, they move at a very high speed. So if there's any loss of oil, or you do not have sufficient oil in your engine, then you have what you call oil starvation. And oil starvation can increase frictional losses. Okay, frictional losses, or not just frictional losses, it's also free friction energy is normally converted into heat energy. It can cause a rise in temperature of the engine. It can also cause damage of some of the parts. So it's not a very good thing. So oil level check is a very critical part of engine maintenance. That's what technicians will always tell you. So you always have to check it either based on a scheduled maintenance program or simply based on the cycle of use. How often are you using it? Because you could say that we are going to do engine change after maybe 6 months. Okay, but during those 6 months, you've covered the distance of maybe 10,000 or 15,000 kilometers. And you're supposed to change your oil after every 3,000 kilometers. So it can also, oil change can be based on things like, for example, the mileage. Okay, it can be based on mileage. There are some that are recommended to be changed after, say, 5,000 kilometers, 3,000 kilometers, 8,000 kilometers, depending. Okay, yeah. So you'll get some type of oil. For example, the semi-synthetic can go up to 5,000 or 7,000 kilometers. Fully synthetic can go as high as 10,000 or 15,000 kilometers. So it really depends. Now, usually oil change is accompanied by change in the oil filter. So the oil filter usually just collects any dirt and debris, any kind of particles, mechanical, from, say, for example, whatever it is in the engine, it normally collects it. So that very critical parts, for example, the crankshaft. The crankshaft is made of, is usually machined to very high tolerances. So sometimes, as the engine is functioning, sometimes you have some parts chipping off. Okay, those parts can easily cause damage to certain sections of the engine that are machined to very high tolerances. So that's why the oil filter is normally meant to collect any dirt or debris that for one reason or the other could get itself mixing with the oil. Okay, some of the dirt could even come from, by the way, the combustion processes. Okay, some of the unburnt carbon can easily end up in the oil that is circulating, and the oil circulates at a very high pressure. So the air filter, sorry, the oil filter normally collects all that. Air filter is also sometimes so it's okay. It's a very common thing. I've seen quite a number of mechanics always insisting that whenever you're changing the oil and the oil filter, also change the air filter. It's not standard practice, but it's a common practice. Okay, so the air filter does not really have anything much to do with the changing of the oil, but it is normally just recommended that they be changed together because it's something that is quite easy to forget. So it's usually given as a common practice rather than a standard practice. The air filter can be changed at any time, does not need to be changed when the oil is being changed. It's common misconception in the industry. Because if, for example, you're operating in a dusty environment, very, very dusty, maybe you're always operating off-road, or maybe unatumia diesel generator yako kwa place yenye kuna always there's a lot of dust and dust particles and all that, then the oil filter, the air filter can be changed as frequently as is needed. Does not need to wait, for example, 5,000 kilometers for the oil to be changed so that the air filter is changed. They have no relationship at all. Okay, so the air filter is normally just to protect the integrity of the air that is going into the intake manifold. Okay, so because if that filter, if that filter is, say, for example, blocked, if it is choked, okay, then you will have less quality of air going into the intake manifold, which means that it affects the efficiency of your engine, especially in terms of fuel economy. Okay, so it's usually just recommended that they be changed together, but where possible, if you're operating a very dusty environment, change the air filter as often as you can. Does not need to go with the cycle, because assuming, for example, that you change your air filter and together with the oil, and your oil is going 15,000 kilometers, basically you make oil synthetic. If you're going for a distance of, if you're operating a very dusty environment, you will not have to wait to cover 15,000 kilometers in order for it to be able to change. Makes no sense at all. Makes no sense at all. So the air filter should always be changed according to, especially, the environment within which you're operating. If you're operating within a city road, then you normally don't have a lot of problems. Normally don't have a lot of problems, especially with the need to change the air filter, because now you do not have a lot of what can I say? Haichafuki, I don't know, I'm looking for the right term. So haichafuki haraka. Okay. So if you are operating a very dusty environment, especially kama unafanya off-road, we'll change air filter yako as often as you can, because hazikwangi expensive. I think air filter inakuwa kitu 1200 kwa magari mingi, between 1200 na 2k. It's not something that is very expensive, so it does not have to be changed together with the oil filter or the oil. They have no relationship. One functions as a lubricant as well as a coolant for the engine. The other functions as a filter for the air going into the intake manifold. Now, so there are quite a number of things. I could go on and on and on and on, but those are maybe those are the things that I can think of. But I want you to also dig into so that you can be able to know what would you be looking for if you have, for example, your engine overheating. What could be some of the issues that are causing your engine to overheat? Okay, for example, one of the reasons could be you have maybe the coolant pump is not working properly, for instance. So there are quite a number of issues that could be coming. So you always have to ask yourself those number of things. So I know there are those who've done a lot of this maintenance and all that, but the coolant also plays a very important role. We'll come to the there's a topic we have pale mbele where we'll talk about the cooling process, air coolants and all that. Maybe we will really talk about the coolants and all that. Like, for example, if the engine is overheating, you normally have to look at a number of things. There are quite a number of things that you could be looking at. So we'll talk about them as we proceed. We'll just talk about them as we proceed. Now, so these are the car engine parts and all that. We'll talk about that one. So crankshaft inakaa hivi. So like I said, at any given time, if this is so this is the way we normally count is that one is here. So this is cylinder number 1, 2, 3, then 4. Okay, so this is here you have this flange. This flange here is where you normally place the pulley. Okay, then here is where you'll fit your flywheel. Now the camshaft looks like this. You can see the camshaft has different shafts, cams facing different directions. So the whole of it is a camshaft. Iote is a shaft. You can see that is a shaft. Now cam ni hizi. So these are the cams. Okay, these are the cams. If we had a chance of meeting physically, I could be able to show you basically, physically also the arrangement of these cams. Because also with this arrangement of the cams, you can see this one is facing one direction, another one is facing another direction. So that offset in terms of the positioning of the cams is simply to effect or to impact the opening and closing of the intake and exhaust valves alternately. For example, unapata kama moja, if the first one is controlling the opening, the intake valve, then another one is operating the exhaust valve. Okay, so usually alternates like that. So more they are for one cylinder. Okay, so you'll find just a number of them as you proceed. For example, you can see there's this one, there's the 2, 3, 4, no 3. So this one and this one, there's 4, this one and this one. Okay, so some other cams here, some other cams are used to operate. Say, for example, the distributor is also operated by, especially the mechanical type, kuna distributorless systems, but the mechanical distributors are also operated by a cam, because like I said, it has to be synchronized. The function of the distributor has to be synchronized with the opening and closing of the valves, as well as the reciprocating motion of the pistons. Okay, so you'll find the same camshaft that operates the valves is the same system that also operates the distributor. So you'll also find some extra cams here that can be used to operate. Pia hapa kwa hii cam, especially there'll be some engines you'll see. The cam is also used to operate the oil pump. So pale kwa nini, pale kwa engine chini yake, okay, pale chini, this oil pan here. Okay, this oil pan here, we call it the reserve. I don't know whether iko hapa, but yes, there's an oil pump. There's an oil pump somewhere. This is the oil pump. So this oil pump mostly inakuwa ni mechanically operated. So it's usually mechanically operated. So you'll see that oil pump is because you'll find, for example, where is the camshaft? You can see this is the camshaft here. So that is a camshaft here. So the camshaft and the oil pump usually are mated. So they have a mating surface together so that the rotation of the camshaft also operates the oil pump. So ukiwashenga gari yako, there are so many things that go into motion. Okay. So the first thing is, once the pistons move up and down, there'll be a rotation. Once you get some firing, okay, you'll get some combustion process, you'll get your camshaft rotating. Camshaft will rotate the camshaft. So the crankshaft will rotate the camshafts, and the camshafts will operate the mechanical pump. Now that pump will pressurize the oil, so the oil will start moving. That's why it's usually advisable that once you switch on your car, especially from a cold start, especially kama maybe ulikuwa umepark gari ni usiku, asubuhi very early in the morning, it's usually good to allow the car to, to run for a few seconds. Could be up to a minute or two, for two reasons. Number one is that at that temperature, the engine does not have, or the temperature in the engine is still very low, and you need the temperature in the engine to sort of catch up or to build up so that you have a more efficient combustion process. So usually the combustion efficiency at cold start is usually very low. That's why most of the time ukiwasha gari, ukiona pale kwa tailpipe utaona moshi mingi. It's because there's a lot of incomplete combustion going on because the temperature in the engine is still very low. So the temperature has to get to a certain point for the combustion process to become efficient. Okay? Or what you'd call optimum. Not really efficient, but optimum. Number two is that the oil is usually settles at the, at the bottom of the engine. Okay? With the oil reservoir. So you have to, if you were to just switch on your car and move, some parts of your engine could be oil starved, all right? That oil starvation is not very good, okay? So you have to usually let your car to allow the oil to circulate, okay, for a few seconds or a minute or two, because in any case usually very highly pressurized, so it will move in very quickly within a very short time imeshazunguka, so that all the parts that are rotating, especially very high speeds, because you can imagine the crankshaft could be rotating at speeds of even at idle speed na around 800 rpm. That is a very high speed. You can convert that into angular speed, yeah, in rads per second. Do you how fast it is? So 800 rpm, 800 revolutions per minute is very, very high, even at idle speed. And of course, if you were to just move, usually that idle speed in a rush up to around 2000 rpm. So not 2000 rpm and the oil has not properly circulated in the engine is not a very good thing. So it's usually just good to allow your car to catch up. And some of the infotainment systems, for example, those that control the camera and all that, sometimes they take time to catch up and to switch on and on. Okay, so just good. So it's kind of like, for example, if you imagine somebody waking you up, ulikuwa umelala, mtu anakuamsha na anakusukuma ukimbia, nataka ukimbie immediately. Unaona hata wewe ukilalanga, you normally have to wake up, you format kidogo kompyuta yako, you format, uanze kujua uko happy, uone alarm ni saa ngapi, akili na reset kidogo tu, ndio you have to do your own duties. So the same thing for machines. Okay, machines, even your laptop, always requires sometimes for all its processes to sort of catch up. Now, so the other thing that I want to mention is okay. So by the way, so for the camshaft, you can also determine the firing order kwa camshaft based on the orientation of the intake and exhaust valves. So if you can get a camshaft, kwa wale nyako industry pale, I'm just challenging you to go uchukue camshaft. I know for those who are working in mechanics, unaweza ikaipata kirahisi. Jaribu uone kama unaweza pata firing order based on the arrangement of the, if it's a four-cylinder engine, check all the arrangement of all the cylinders and then see if you can get the firing order. It is so easy to do that as well. Okay, it's something that I've done it so many times. It's something that is very easy to get the firing order from the arrangement of the piece. Sorry, the arrangement or the orientation of the cams along the camshaft. Now the engine configurations hizo tulikuwa tumeziongelea. Kuna inline, V engine, horizontal, W engine, VR engine, radial engine. Okay, but this nilikuwa nimepeana some few niniko not, so you can be able to check them. The V engine, you can see the way it looks like. I also want you to compare a V engine. So make a table. So this is just like an exercise I'm giving you between a V engine and an inline engine. Okay. So inline na V engine, what are the advantages and pros and cons? Okay. So V na inline, I want you to make a table, compare them. You must be able to understand what is the main difference between a V engine. Not even in terms of structure, but in terms of function and efficiency. Okay. What are the pros and cons in terms of both function, efficiency, and etc. etc. Okay. So compare, make a comparison between the V engine. What are some of the key parameters that you might look at and say, well, this one makes it a bit better than the other one. That's what I want you to look at. So in vehicles, you normally have what you also call the electronic engine management system, the ECU. So ECU kwa gari ni ile munaitanga computer. It looks like this. I think there's an image nimeweka hapa. Yeah, hii computer munaitanga computer ya gari. Now, this one here is the brain of the vehicle. Okay, so it also controls. Somebody is calling me. So now, sorry for that. I had a call. I had to take it. So the what you normally call the computer controls quite a number of things in the vehicles. I'm just going to talk about it very quickly. So for example, here, iko na microcontroller. Oh, they've probably studied microcontrollers, but I'm sure you probably may have studied microcontrollers. So microcontroller is a very powerful it's a very powerful device that consists a lot of integrated circuits and all that within the that is used for to control a number of processes. You will see, for example, processes such as if not even for vehicles, but even things like they help, for example, the computer to even carry out certain instructions, for instance. Now here, the engine control module determines where to set the throttle. Okay, for example, when you set your car to economy mode or eco mode, for instance, okay, you don't need to tell you simply set it, and from that shift, okay, because when you are setting it, you're sometimes inakuwa ni a button, right? You are going to eco mode. So usually just a button. Now that button presses against an actuator. That actuator sends a message through through a sensor. Okay, and that sensor, for example, there are quite a number of sensors. So one of them, if you see here, kwa hii image, kuna throttle position sensor. So that throttle position sensor will determine the position of that throttle determines how much air and fuel is allowed into the engine at any given particular time. So if it chokes the amount of air and fuel coming in, okay, or especially air, if it chokes the amount of air that is coming in, then you reduce the throttle. Like you basically reducing the mass of air, okay, or the mass flow rate of air going into the engine. If you do that, therefore, it means that you are also limiting the amount of power that will be produced by the engine. That's why usually when you are in eco mode, it's usually a fuel saving tactic. Okay, it's usually meant for the engine to take in as least amount of fuel while producing the just the right amount of power that would be required for that particular operation. Okay, so if you go to, say, for example, sport mode, usually it's wide open throttle, WOT. So you are letting in a maximum amount of oxygen now through the air, okay, which will of course mix with air with fuel, and you'll get the most amount of power. So what you are simply changing is the position of the throttle. So the throttle here is an actuator. Okay, now it requires a sensor. So there's a difference between the throttle itself and the sensor. Okay, so the ECU is the brain. So I want you to think of the ECU being a brain. All right, the ECU is a brain. Now, if, for example, you are moving your hand and your hand moves into a fire, okay, kaguza moto, what will happen? So you will find yourself pulling out your hand very quickly. Now, for you to be able to pull out your hand, there has to have been a signal that was sent to the brain saying that the temperatures here are extreme. So the sensor in your finger, the neurons in your finger are now the sensor. Okay, so it will send the signal to the brain, which is now the ECU compared to the ECU, and the brain will now return a signal to the muscles, okay, instructing the muscles to move away the fingers or that part of the body away, okay. So the muscles and the hand now are the actuator, okay. So I want you to know that there is a difference between the sensor, the actuator, whatever it is that carries out the instruction, okay. So the sensor simply send and receive instructions. They do not carry out the instructions. So you always have to remember that. But the instructions are normally carried out by now the components such as, for example, in this case, the throttle position, the throttle itself. Okay, so the throttle position is changed based on an information that was sent by the sensor to the ECU. So the ECU will instruct the throttle to do A, B, C, D. So we also have other things. For example, it can determine how much fuel to inject. So the fuel injectors, so you have a fuel injection, so there's a fuel level sensor, for instance, or even the throttle position sensor, because the position of the throttle also determines how much fuel will be injected at that point. Okay, so also when to fire the spark plugs. Okay, It will also determine the regulate the power distribution, provide onboard diagnostics, and all that. So if you have, for example, a certain kind of fault in your system, say for example, maybe there's an incomplete combustion in your there's a complete combustion in the engine. So if there's an incomplete combustion in the engine, then you usually have the exhaust. Nataka uone sensor number 7 and 8. So sensor number 7 and 8, number 7, which is an oxygen sensor, will measure the amount of oxygen molecules that are present in the exhaust gases. Okay? It will also measure it, so it will go through the catalytic converter and also measure it after the catalytic converter, that is at number 8. So it will compare the two of them. So if there is too much oxygen that is being found in the combustion gases, more than it would be ordinarily expected, then the engine, the ECU, will receive information from the sensors that the comparison of these two figures shows a very high level of disparity. Okay, so it will give you a check engine light. Now, once you get the check engine light, it is now you to go and decode, because usually go and carry out some diagnostics. You can go do an onboard diagnostics. It will be able to give you what that error signal is. And usually that error signal is normally in form of a code. You go and decode that code, you can even put it, you can as a Google, you check it, and then it's maybe telling you that there is excess amount of oxygen in the exhaust gases. So it sometimes cannot tell you what exact problem is. It tells you what that symptom means. Okay, it's kind of like when you go to a hospital, you are feeling some headache. Then the doctor has to do a lot of tests. Sometimes one test is not enough. You do another test. You do a blood test, there's nothing showing up. You do something else, some other test is not showing up. And then but every time you do a test, it could be narrowing down to a problem. So the diagnostics process is also usually like that. So if it points out to, say, for example, an excess amount of oxygen, then you could simply narrow down to, for example, the incomplete combustion process. So one of the things you could do is, for example, change the spark plugs. Okay, change the type of fuel, or maybe wherever you normally get your fuel. Could be the fuel was just bad. It could be maybe, for example, there's a clogged air. I mean, there's some clogging in the intake manifold. Okay, it could be maybe you've not changed your filter for a very long time. It's getting clogged. Okay, you're not getting sufficient amount of oxygen, so you're not getting the right air-fuel ratio, for instance. Okay, it could be just the spark plugs are worn out. It could be that the ignition coil is not functioning properly. So there's a misfiring. If the ignition coil is say, for example, burnt out, then it could be that maybe there's a misfiring, and so it means that in some fire, so some power strokes do not happen. So you have maybe some power strokes not happening. Okay, and it can sometimes become easy to narrow down to some of these problems based on the mechanical behavior of the car as well. For example, if you are having some incomplete combustion in some of the cylinders, especially if you have very worn out spark plugs, then it means that you are having intermittent power production, which means that sometimes you are skipping some power strokes. If you skip some of these power strokes, then you will have a very inconsistent production of power. Na sana sana utajua based on sometimes it shows as some vibrations in the engine. Okay, so you'll have in some cycles you have some extreme vibrations. Okay, because there's an imbalance in power production. So those extreme vibrations can also be just a very mechanical way of also pointing out or narrowing down to some of those problems. Sometimes the problem is not very obvious. Sometimes it can also just be tested by even basically just driving the vehicle and just observing the way the vehicle is behaving. And if you are guiding if you are very experienced enough, sometimes you narrow down the problem faster. So kuna quite a number of sensors that are controlled by the ECU. So nimesema kuna air throttle position sensor, air flow sensor, the fuel pressure sensor. The fuel pressure sensor, if the fuel pump is worn out, usually the fuel pressure sensor will send a signal to the ECU. Now the ECU could display a dashboard that maybe there's a check engine light na kulete kama check engine light. Okay, crankshaft speed sensor ni ile inakuonyesha how fast the engine is moving na inapeananga in terms of RPM. So ilukiananga pale kwa gari dashboard unaona RPM like 1000, 2000, 3000 RPM etc. Then that is hiyo ndio ile RPM ya gari. That's basically how fast the crankshaft is turning. So it's a pointer of the speed at which. So when you say the engine, there is the speed of the engine, you're basically talking about the speed of the crankshaft. Because anyway, the main power outlet of the engine inakuanga kwa crankshaft. Hakuna kwingine. Now the knock sensor, so you also have the temperature sensor. The temperature sensor ni ile if so for example you are having an engine overheating, it will always show you kwa temperature sensor. But most modern engines, when there is a temperature rise, so temperature can rise, like I said, for a number of reasons. Maybe the coolant pump is broken or worn out, it's not working. Okay, some of they are usually hoses that carry the oil, so the coolant. Sometimes they are not properly tightened, so you are leaking some coolant. The coolant level imeenda chini, you'll also find temperature rising up. When the temperature also rises in the engine, usually there is the ECU sends a signal to the fan. There's usually a fan that is placed behind the radiator to come on, so that it simply increases the rate at which heat is lost the radiator fins. So also, if that fan is for example is malfunctioned, there's a fault in that sensor. There's a fault in the fan is not functioning. Usually the heat loss process is not efficient, so the temperature can also rise. So it can also be a problem like that. Okay, so the temperature can rise for a number of reasons. So you always have to watch out for quite a number of things, especially near the cooling, just the cooling process of the engine. Okay, the cooling process is not efficient, you'll have temperature rising. Now your temperature sensor na ikwangi moja, so temperature sensor is not usually one, especially with more modern engines. You normally have temperature sensor, it's around 2 or 3 positions around the engine. Okay, so those temperature sensors will simply usually send information and compare the temperature at different positions of the engine, and then it will say whether there's a good balance between those 3 values or 4 values, depending on the position of the sensor. Na kuna kwa na that information pale kwa infotainment system kwa gari, so you'll always get you'll always get something that is showing the engine there. The dashboard that is showing the temperature. Na kitambo ulikuwa unapata ilikuwa ni mechanical arm, ilikuwa ina move from, ni kama ile ya fuel. Kitambo there was a mechanical arm showing H, that is high and low. Yeah, so pia ya temperature kulikuwa na mechanical arm that was just connected directly to the thermostat. Okay, but these days you simply have digital meters, digital systems that simply show, for example, in form of a code. If it's green, it means the engine is it's fine. The temperature is within normal operating limits. Okay, if it turns to yellow, it means something is wrong. If it's red, it means that there's an excessive amount of heat developed by the engine. But most modern vehicles also do not allow for the engine to overheat. Usually it goes into safe mode, or what you call the limp mode. Okay, so when the engine starts overheating, it normally goes into a limp mode, and allows you just sufficient amount of power for you to, say, for example, go maybe to a curb or to a petrol station, or so simply move to the side of the road. Kuna kuanga na zile sections za highways za breakdown. I hope unazijua. There is usually those sections zinakuanga zinatumika for breakdown. Yeah, so it can allow you to move to such places, and then unaweka hazard na unaweka hizo those things zinaonyesha that there's a problem with the vehicle, you can get it towed and all that. So when there's an overheat, the overheating, like I said, overheating can occur for a number of reasons. Maybe there's no coolant. Maybe you are leaking some coolant. It could also be that maybe your radiator is corroded. There's usually, especially if you're using the wrong type of coolant. Kama maji, so kuna watu wamezoea sana maji, it usually corrodes some sections of the radiator and can start leaking some coolant. Also, sometimes we're using the wrong type of coolant, or even using water as a coolant. Water as a coolant is not a very effective. So although the coolant is a water base, but kuna kuanga na additives that normally make it better. They make their cooling ability much better. They simply improve the ability of the coolant to to take away heat from the I mean from the engine block. Okay, kwa sababu kwa engine block kuna kuanga na kwa engine block, if you see this image here, pale kwa engine block kuna kuanga na, if you see, I don't know whether I can be able to show this. You can see that kuna tumashimo kwa engine block kama hizi. So hizo mashimo hizi, these ones here. So hizo mashimo unaziona kwa engine block, they are coolant jackets. So they allow coolant to go into the engine block. So the engine block is not like a solid mass. Okay, they usually have channels inside that allows the coolant to go in and come out and move around and all that. So when the heat developed is normally circulated within the engine using the oil. Kunakuwa na ile oil. Nilisema oil functions both as a coolant as well as a lubricant. So it will deposit that oil, so it will carry out some of the heat deposited to the walls of the engine block. And then now on the other side of the engine block, the coolant circulates and takes away the heat. So the coolant and the oil do not mix. All right, the coolant and the oil do not mix. They simply exchange heat across a wall. Okay, which is part of the engine block. So it behaves as a heat exchanger, if you know how heat exchangers work. Anyway, so I just wanted to mention that fact. Now, so I was talking about the number of sensors. Kuna pia za ignition control, kuna fuel injector. So kuna so many types of sensors. Okay, so many types of sensors that are normally controlled by the ECU. So it's also you to also read about the ECU, how it functions, and all that. Okay, so kwa hii system tunaona kuna the electronic stability controls system. Okay, kuna anti-lock ABS, kuna zile zina control the ABS, etc. etc. Okay, so there are so many of them. So types of sensors, kuna hizo pedal position sensor, throttle valve position sensor, engine oil temperature sensor. Inakuonyesha pia oil temperature. The oil temperature can rise, by the way, the oil temperature can rise for a number of reasons. For example, if you've used the oil for a very long time and you have not changed it, the oil breaks down, by the way, after a very long use. So they break down the specific chemical, the chemical formula or the chemical structure of that oil. After a very repeated use, under very high pressure and a very high temperature, it breaks down. Na inafika mahali inakosa ile ability to carry away the heat or function even as a lubricant. So in that case, therefore, sometimes you find that it's also not efficient or effective in terms of, transporting the heat that is developed in the very internal parts of the engine where the coolant cannot reach. Okay, so you find that the temperature of the oil can rise for that reason. So it gets heated up instead. So inafika mahali hata ina boil. Okay, so it gets heated up. So it's also usually a pointer of the need to change the oil. Induction air temperature sensor. So ile air ambayo inaingia pale kwa engine pia also has to be regulated, especially where there is forced induction. Kama for example unatumia turbocharger na supercharger. So you also have to control the air. If when you compress, turbochargers and superchargers in a compressed air. And I talked about the compression process being a process of increasing kinetic energy and the vibration. And it increases the temperature because of that, the temperature of the molecules. So if the temperature goes up too much, if it's not regulated, especially when there is forced induction through superchargers or turbochargers, pia huwa inaleta shida. Because it means that for petrol engines, for instance, if there is a very high temperature kwa air, the intake gases, pre-ignition can occur. That is, if there's a very high temperature, sometimes it can auto-ignite the especially petrol. Petrol is very volatile. Yeah. Na pia even for example, even for example for diesel, pia they can also auto-ignite. So it's not a very good thing. So usually when you have forced induction, for example, when you're using a supercharger or turbocharger, kuna kuanga na intercooler. Okay? It's something that can be, so it's a heat exchanger. For those who have worked in cars, I'm sure you've probably seen this. So kuna kuanga na intercooler. So you have to, so once you compress the air, for example, kwa supercharger or turbocharger, either both turbochargers and superchargers zinakuanga na intercoolers most of the time. So that intercooler simply cools the air or reduces the temperature of the intake gases so that it does not cause problems, say, to do with auto-ignition, because your auto-ignition causes issues like knock. Okay. Pia EGRs, we'll talk about an EGR later, that is exhaust gas recirculation. So EGR systems also usually require intercoolers. Okay, so we'll talk about exhaust gas recirculation and what it means, especially when it comes to control of emissions. So tutaongea kuhusu hiyo, but also EGR systems also require intercoolers. Na hiyo induction air temperature sensor ndio ina send information to the ECU. So if there's a problem, then the ECU will always notify you, say for example through a check engine light. Natumika kuzo oil pressure sensor. If the oil pump in the engine is dysfunctional, your oil pressure sensor it send information to the ECU. So it becomes very easy with all these types of sensors to be able to easily diagnose internal combustion engines in modern use. Fuel level sensor ni ile inakwambianga mafuta imeisha. Hiyo nyinyi mnajua. So kuna watu wengi sana mnapendanga, wale mko na magari mnapendanga kuendesha gari mpaka gari izime ndio unaenda unatafuta kuongeza mafuta. Yeah, so it's usually not a very good thing to starve the vehicle of fuel, because also the fuel also acts as some type of a coolant for your fuel pump. So it's not good to drive the vehicle na ukisema ati mimi najua gari yangu. So it's always not good to starve the vehicle of fuel, so that you're always driving it in very low fuel all the time. Wheel speed sensor ndio inakuambia sasa una move at 50 kilometers per hour, 30 kilometers per hour, 40 kilometers per hour. So usiconfuse wheel speed sensor na ile ya RPM. Kuna hii nilikuwa naita crankshaft position sensor. Okay, so the crankshaft speed sensor. Yeah, so by the way, kuna crankshaft position sensor na crankshaft speed sensor. Those are two different things, but in some vehicles you will find a crankshaft position sensor, and then after that you have a PID controller, and the PID will simply integrate the position into speed. Okay, so huwa ina integrate tu, pia ikitaka acceleration ya hiyo nini, it will simply integrate it. So sometimes iko na an integral, it's part of the control system ambayo inaiko pale kwa ECU. So it does not really need sometimes it simply needs a position sensor. Hiyo position sensor inakuwa integrated by the ECU, iko na an integral hapo, unajua mathematics vile inafanya, and then itakupatia speed. So you simply integrate and you get speed. Okay, so that is how it works. So sometimes you don't really have one that measures speed, but rather one that measures position. That is the changing position per unit time. So you know the mathematics behind position and speed and all that. So anyway, so I was saying that wheel speed sensor ndio inakuonyesha sasa the speed at which you are moving, 50 kilometers per hour. But ile RPM is the speed of the engine, which in this case is the speed of the crankshaft. So do not confuse the speed of the crankshaft as well as the speed. But both of them will show you the dashboard. Both of them utaziona. Kuna ile iko pale inaonyesha times 1000 RPM, na ingine inaonyesha in terms of kilometers per hour. Pia kuna torque sensor, knock sensor, airflow sensor. Airflow inakuonyesha the speed at which, or the mass per unit area of fuel and air that is coming into the engine. So hiyo pia huwa inatumika kudetermine the air fuel ratio. Na pia by the way, the airflow sensor pia ndio inakuambianga kuhusu, kuna watu who normally pay attention to this nini inaitwa aje, I'm forgetting, unasemanga kilometers like the fuel usage. Okay, it usually gives an idea of how much fuel is going into the engine versus the amount of power being produced. So it normally compares those two na inakupatia kitu inaitwa fuel economy, like for example how much like you are consuming. So it can give in terms of maybe the amount of fuel you are consuming per kilometer. That is, you know, for example, you see like kilometers per liter. So it simply gets information on how much fuel you are combusting or you are using every kilometer, and then how much power you are producing. So it normally just carries out some using an algorithm, and to be able to give you those mathematics in terms of the fuel consumption, say per kilometer, or the number of kilometers that a liter of fuel will get you. So it can be as complex as depending on the type of car that you are using. So kuna zile magari itakupatia even some more complex information about the amount of the fuel usage. Okay, sometimes even comparing how much fuel you are using versus how much power you're producing, and it can also be a good way of even determining whether the fuel that you are using is of a good quality. Okay, So usually those kinds of sensors ndio nakupatia information. So nimesema kuna crankshaft position sensor, camshaft position sensor, manifold absolute pressure sensor, coolant temperature sensor, etc., etc. So kuna so many types that are usually in place. So the ECU sensory system, so the ECU sensory system, so hiyo ni hiyo computer nilikuwa nimesema, it normally gives information. Pia ile diagnostic kit, kwa wale watu unaonanga kwa diagnostic kit, you normally plug it just the section that is connected directly to this ECU system. Na iko na all the information kwa hiyo gari, gives you all the information in the car, and can also be used to even program, for example, even the car key and so many other things. So inafanyanga a lot of multiple things anyway. Okay, quite a number of actuators. You can see kuna fuel injectors. So the fuel pressure sensor communicates with the fuel injector. So if the pressure is too low, then it maybe the engine now instruct the fuel injectors to increase the pressure. Spark plugs, okay, so the spark plugs, if for example there's a misfire, it will always look at the spark plugs. The kind of diagnosis normally are the spark plugs. If they are misfiring, then itakupatia a check engine light immediately, and you can be able to pinpoint it. That maybe the spark plugs are the ones that are giving you a problem. But sometimes for spark plugs, sometimes the problem is not very obvious, and sometimes it requires you to physically inspect the spark plugs. And we'll talk about some of the things that you normally look at when it comes to the spark plugs. But usually they do also get worn out, and they are normally meant to be replaced after some period of time. So kuna EGR valve, we'll talk about the EGR. I don't want to assume that everybody knows, probably some of you know, but we'll talk about the EGR valve. But the EGR valve usually controls the, so with the EGR system, you normally have a percentage, around 20 to 30% of the exhaust gases being recirculated back into the intake manifold, so that it is mixed with air and fuel. Okay? So I know it sounds weird, but sometimes you reroute some of the exhaust gases and then you combine it with the intake gases, that is air and fuel, and then you combust them together. Usually inakuanga ni something that is normally used for emissions control. So we'll talk about them. So when there is usually the oxygen sensor usually takes the readings before and after the catalytic converter, and then it will send information to the EGR valve, say for example, to open. Okay, so the EGR valve simply carries out instructions. Also, the EGR valve usually does not come into play, especially when the vehicle is moving at, say, usually below 50 kilometers per hour. So it's only once you are cruising that the vehicle may simply instructs. So inatumia ile wheel speed sensor to determine that the vehicle is now moving, say, above 60 kilometers per hour, and then the ECU will use that information to instruct the EGR valve to open, so that now some of the exhaust gases are rerouted back to the intake manifold, usually as an emissions control issue. So I'm just giving you the way some of this information is relayed. So the EGR valve usually uses the wheel speed sensor to determine at what point to open. Just showing you how they all relate, but they all require to communicate using the ECU. So ECU inafanyanga hiyo kazi yote. Now kuna fuel tank venting. Okay, fuel tank venting, it's also, it's also usually for, okay, this one can, you'll find them, for example, when there's excess buildup of moisture in the fuel tank, for instance, inatupikanga kuvent and so many other things. Okay, also when you are also cleaning the fuel tank, or when you are also replacing the fuel pump, okay, it can also be actuated directly by the ECU, or sometimes it can be manually actuated. Cooling fan, nilikuwa nimesema cooling fan, when the temperature sensor in the engine inaonyesha that the temperature is rising, then the cooling fan usually kicks in. So, but it's usually instructed by the ECU to do so. So you can see the relationship between the different sensors and different actuators in the engine. Throttle position should be throttle position sensor, not the throttle position motor. So kuna kwanga na very small motor, usually natumia, I don't know, I've forgotten how many voltage, natumika around 5 volts ama ni ngapi. So it's a very small motor, ndio ina change the position of the throttle. So the throttle position is normally changed by a throttle position motor, and that information is usually obtained by the throttle position sensor. Okay, kuna check engine light, hiyo kila mtu anajua. Check engine light usually just shows at your dashboard to be able to tell you, for example, if you're having very poor traction of your wheels, unaweza kwa maybe na a puncture, maybe unaweza kwa you've lost pressure in your tire, so you'll find that one of the wheels is not having sufficient traction with the ground, so you'll see that traction control light coming on in your dashboard, and you'll be able to you should be able to check out and see why you are not having that. Okay, so those are some of the things. So generally today's ECMs generally employ a 32-bit microcontrollers with a few megabytes of memory clocked at speeds between 32 megahertz and 100 megahertz. So they generally communicate with other electronic modules using one or more CAN bus interfaces. So inatumia CAN buses. So just a bus is basically a communication module or a communication medium between different parts of, say, the microcontroller or some of the different parts that make up the ECU. Okay, so mimi naweza sema kufikia hapo ninataka ni wache hapo. There was something else I wanted to but pia naona time imeisha, and but I also want to give you a chance to ask a question. If you have, you can type. If you would like, you could type there, or you could ask if you want. But I was thinking, but I'll talk to the class rep to wonder if we could have some. So there are some things so there's some calculations we'll need to do, and I'm going to sort of condense them into some form, because now we don't have the advantage of writing, but we will still need to discuss them, and I was hoping if we could get a class tomorrow, because I know next week Friday is Easter, and I know I'll be in my village, busy dealing very seriously with Mbuzi Choma and so many other things. So I was thinking if we could, but we'll talk to na class rep to go if we can fix some 2 hours tomorrow to PTA. So I will just make them a very easy way, and then tutapitia tu kudiscuss, alafu nitawachia maswali muweze kuzisolve, so that we don't next week at least you'll have something to be working on. Otherwise sitaki muache nyuma compared to the class ya to your class ingine ya regular. So I'm hoping I can get some time tomorrow. So if you are called upon tomorrow, itakuwa ni mzuri, so that we just tutapitia tu, tutakuwa napitia tu tukiongea those questions and all that, and a few formulas, and then mutaweza pia kuuliza maswali. So ikiwezekana you attend, and then kama kuna anything hapo mtakuwa mnaniuliza swali na najibu papo hapo tu. Okay, so I'll welcome any question kama kuna mtu ako nayo, but you have the notes generally, so you can type if there is any, maybe 30 seconds and see whether there is anybody. Kama kuna anybody, kama kuna mtu ako na swali anaweza kuuliza. Okay, so kama hakuna swali, so I'll talk to the class rep, and then let's see ningekuwa mzuri sana tukipatana kesho, so that I don't have to bother you next week, because we will all be in Easter. Okay, so ikiwezekana let's meet tomorrow. So I'll talk to the class rep, and then we can be able to do quite a number of things tomorrow as well. So ikiwezekana ukue kesho, so that kama kuna swali lote I'll be able kujibu, and then I'll also leave you with some questions to solve. Otherwise, mimi niwashukuru for your patience, and have a good night and greet your families. Asanteni sana, and God bless you.